All right, hey, good morning, Allie. Hope all is well. Hope the move's going okay. I just threw a quick video together to go through the ones you're struggling with. I'll do one for 10.6. That's this. We'll do 10.7 later. Okay, obviously these might not be the exact same problems, but hopefully we give you an idea and show you what's going on with these. Okay, here's number 2, and yeah, this one's kind of a pain to do, but I'll give you a trick for doing it. Okay, so this one says name the major arcs in circle O. Okay, now let's talk about arcs real quick. There's 3 types of arcs: major arcs, semicircles, and minor arcs. Let's start with a semicircle. A semicircle is just basically half the circle. Okay, so I could say that arc DBG is a semicircle because it takes up half the circle. I can tell that from this straight line going through my center here. Okay, now when I name that, I need to say DBG, because if I just said DG, I wouldn't be sure if you're talking about the bottom half of the circle or the top half. Okay, so that's a semicircle. We can then talk about a minor arc. A minor arc is just an arc that is less than a semicircle. So for example, FG is a minor arc. Only need 2 points for that, because when I say FG, we're not going in the other direction, we're going in the close direction. Okay, so the actual major arc then is just something more than a semicircle. It's going to take up more than half the circle. So for example, what I could do is I could say that arc CDG, if I keep going here, takes up more than that semicircle I drew in blue. So I know that CDG is a major arc of this circle. Okay, I don't think that's a super tricky, complicated idea to understand. It is a pain in the butt to get all the right answers here. So let's see if I can find the one with a C on the outside, a G on the outside, and then a B or a D in the middle. Okay, the trick with this is that there's different ways I can name this. I could say this is arc CDG, I could say it's CBG, I could say it's GBC, I could say it's GDC. So we got to find one of those. I'm looking for C and G on the outside. I'll show you a better way to do this in a second. CG, but nope, that's through F. Feel bad if you're finding it quicker before me. Where is it? Here we go. Okay, GDC is the way they named it. That just means we're starting at G, we're going through D, and going to C here. Okay. I wouldn't recommend going through the problem like this. I actually started this video doing that 10 times and then said forget that. Here's what I'd recommend instead. Go through it backwards. Start off with the arc name, FGC. Okay, so if I go from F through G to C, I've just got to decide, is that a major arc? It is. It's more than the semicircle, so I'll check that one off. Then I'll move on to B. So I'm working through backwards here. GC, I don't even need to check that, okay, because it's only 2 letters. I know I need at least 3, so I can eliminate that right off the bat. CGD, we'll do that here. C through G to D. Yep, that works. Okay, so we'll mark that one off. And then you can just go through the rest of them, marking them off. There's going to be a whole bunch of them. Okay, like I said, if you don't quite get them all, that's okay. But I'd recommend going through backwards. That's going to be the way to do this problem. All right, this is problem 8. Okay, and it's going to be applied problem of finding circumference. Just real quick, if I want to know the circumference of a circle, the distance around the circle, I'm going to use the formula C equals either 2 pi r if I have the radius, okay, or I could use C equals pi times d, all right, if I have the diameter. Okay, 2r is the diameter, half of the diameter is the radius. Okay, so 2 different ways we can do it. It says a 2-foot wide circular track for a camera dolly is set up for a movie scene. The 2 rails of the track form concentric circles. The radius of the inner circle is 71 feet. Okay, how much further does the wheel on the outer rail travel than the wheel on the inner rail? Okay, that is the question. How much further does something spinning around this track, how much further does the outer wheel travel than the inner wheel? Okay, this drawing's not to scale. In other words, how much more is the circumference of the outer circle than the inner circle? Okay, so what we want to know is, basically, we'll just say outer minus the inner circle. Okay, inner circle, I'm going to start with that. That is this circle right here. Oh, that is the worst circle ever. If I want to know its circumference, I'm just going to go 2 times pi times radius, because I know the radius. So we'll just say 2 pi times 71. And then for the outer circle, what we have is we have this extra 2 feet on top of that 71. Jeez, I'm drawing terrible here. So the radius for the outer circle will be 73 feet. So in other words, we can go 2 times pi times 73. Okay, for these calculations, I'm going to leave things in terms of pi. I'm going to go 2 times 73, which gives me a 146. So I'm going to say 146 pi for the outer. And when I say leave things in terms of pi, that means I'm multiplying the 2 by the 73 and not pressing the pi button on the calculator. 2 times 73 is 146. We could say it's 146 pi. And then same idea with 2 times 71. That's going to be 142 pi. And the advantage of leaving things in terms of pi is this is going to be an easy calculation. 146 minus 142 is just 4. So we could say our answer is 4 pi. Okay, so just like you can add numbers with x's together, you can add numbers with pi's together. And then to finish this off, this one says round to the nearest tenth is needed. Typically, real world problems, we do want to round this at the end. So what I'll do is I'll do the actual multiplication of the calculator. I'll say 4 times the pi button. Okay, you can use 3.14 if you want to. But anyways, 4 pi is just a 12 point, we want to the 10th, so 12.56, we'll say 10.6. That'll be what I plug into my answer box here. I need to quit doing that. All right, on to number 9. In this one, we're looking for the length of an arc. Okay, and what the length of an arc is a piece of the circle's circumference. Okay, so I want to find the length of the red arc. I want to find the distance along the circle along my red. And what that is that's just a fraction of the circle's overall circumference. Okay, that's why the formula we gave you for this is this. We said that arc length is equal to, I'm going to say, the measure of the arc. In other words, the angle that arc makes, divided by 360 degrees. Okay, 360 is the whole circle, so if I put the part in over 360, that'll give me the fraction. And then times, we could say just the circumference, which in this case, since I have the diameter, I'll write as pi times d. Okay, let's fill in what we know here. Now, I don't know this arc measure right off the bat, but since this arc measure is 60 degrees, and I know that here I have a semicircle, half the circle is 180, I'll take 180 minus 60, which gives us 120. Okay, so my arc measure is 120. So we'll take 120 over 360. And in other words, we're dealing with, what would that be? That would be a third of the circle. Okay, so a third of the circle's circumference. And then I'll multiply that by the pi times 66. That's my circumference times the fraction. That's going to give me how much of this circle's circumference is that red arc there. Okay, now this one, notice it says type an exact answer in terms of pi. In other words, leave the pi out. So what I'm going to do on my calculator is I'm going to go 120 divided by 360, skip the times pi, times 66. So again, 120 divided by 360 times 66, that gives me a 22 on the calculator. So what we'll do is we'll write that as 22 pi All right, when you plug this in, you'll actually have to write 22 and then find the pi button when you pull things up. Stop. Okay, last question, number 10. Find the length of the arc shown once again. Okay, once again, arc length is the measure of the arc divided by 360. Okay, times the circumference. And this time I'm going to write in terms of the radius, because I have the radius in this problem instead of the diameter. So we can say it times 2 times pi times r. Okay, so first thing I need is this arc measure. There's a little extra step for that once again. I need to know how much this angle that makes this arc is. And the trick for that is, since I have vertical angles, two angles that form an X, and this one's 25 degrees, I know that this arc measure will just be 25 degrees as well. Okay, there's a little bonus practice from chapter 2 for you, way back in September. Okay, so we can fill that in. 25 is our arc measure over 360 times the circumference, 2 pi times the radius, 36. And then once again, what I'll actually plug into my calculator is 25 divided by 360 times 2 times 36. Leaving the pi out, and that gives me a 5. So we'll say 5 pi because I didn't include that in my calculation. That'll be what goes in there. Okay, hopefully that helps. Let me know if you're still stuck on a problem. If we need to, you could maybe send me a screenshot of the specific one you're on, and I could help you more with that. But like I said, hopefully that helps. I'll make that second video. I'm going to try to exit without pulling